Hello everyone, in this recording I will talk about the binomial distribution. Binomial distribution is having a Bernoulli trial. Bernoulli trial means that we have two possibilities for the outcome. It is either success or fail, as in the coin example, flipping coin. And the outcome of each trial is constant. So what it means is that, for example, you tried once, so first trial, and then outcome is, for example, it is either success or fail, and the chance is 50%, yes. And then you try the second trial, then outcome of success and the failure should be 50% as well. So it is requirement, and it should be independent. So first trial should be independent and the second one, and it should not affect the second trial. This is the Bernoulli trial, also called, like a flipping coin. So if you flip the coin multiple times, it doesn't matter 100 times, 200 times you flip. At each flip, you have 50% chance, and the next flip is not affected by the previous one. This is what it means by the Bernoulli binomial distribution. And then we are drawing random samples with a replacement. This is important. We just replace the samples back. And then the possibility of having defects in a randomly drawn sample. So possibility of having defects in a randomly drawn sample is this formula, and the D is the number of defects. So having defects equal to D. Possibility of having defects equal to D in a randomly drawn sample is the combination multiplied with the number of defects in lot, number of defects in sample, lot size, and the sample size. And I forgot to add here is that the P is the probability of failure, or you can say non-conformity, or you can say the defect. Okay, so there is an example here. It says that we have a machine that may develop a fault with a probability of 0.003 in 3 years. So what it means is that if you operate this machine, and there is 0.3% chance that it will fail in 3 years. It's like your car may fail in 3 years with a chance of 0.3%. If we choose 50 random machines, what is the probability that 49 or more will not develop any faults within the first years of operation? Okay, so we have the 50 samples. Okay, 49 no defect means that we have the D is equal to 1, the number of defects. 50 no defect means that the D is 0. So 1 defect and then 0 defect. The question also says that in other words, probability that 1 defect is there. Okay, this is the question that also says. Okay, let's now solve it. So firstly, I will start with the probability that we have 1 defect, and then probability that no defect. Okay, let's start with the first one. We have 1 defect. If you remember the formula, the X is equal to 1. If I go back, so D is the number of defects, and then N is the sample size. Sample size is 50 and number of defects is 1. So I will just select 1 out of 50, and then the p is the failure 0.03, and then to the power of d, which is 1, and then times 1 minus 0.003 times the n minus d, which is 50 minus 1. Similarly, the probability that x is 0, this one is no defect. Okay, that means out of 50, 0.003, 0, 1 minus 0.03, and 50 minus 0. You can calculate it in Excel. Let's do that together. So I have 1, I have 50, I have 0.03, I have 1 minus 0.3, and I have 0, I have 50. Okay, now let's do the first calculation. So it will be that the combination of that is 50, and we choose 1, times this one to the power of 1 times this one to the power of 50 minus 1. Okay, this makes a 0.31412494, so it will be 0.1295, let's say. And then we will do the same stuff for the next one. So it will be that the combination of the 50 and then 0 and then times, and then this one to the power of 0 times this one to the power of 50. So that will be 0.86, 0.8605. Okay, and then the question says that 49 or more. So it says that then we have to look for x is 1 plus that x is 0. Okay, this is what the question says, and that will be equal to, if you add these two numbers, it will be 0.989999 or 98.99%. So as you can see, it is very, very high percentage. So it means that we don't expect failure in 3 years. So the confidence is 98.99%. Okay, or you can say that the possibility of having one or zero defect in 50 randomly drawn sample is 98.99%, which is a very high value because the p-value is small. You can see the p-value is very small. Okay, this is the end for the binomial distribution, and the next one I will talk about the Poisson distribution.